Very good morning, students. For this lecturing video session, I am going to cover up the second chapter of Unit 4, which is Development of Surfaces. In the previous lecturing videos, I have explained in a detailed manner about the first chapter, which was sections of solids, right? For this session, I am going to cover up the second chapter of 4th unit, which is nothing but the development of surfaces. What do you mean by development of surfaces? See, the development of surfaces of an object means unrolling or unfolding of all the surfaces of the object on a plane. See, a typical example is your toothpaste carton, isn't it, of the shape of a square or rectangular prism. For an example, so I have a cold bomb carton, right? This has this square in shape. The top face is square in shape. Therefore, it's assumed this is a square prism, isn't it? So, what I have to do is now open its top and bottom bases. Top and bottom bases. I'm just cutting and throwing it off. Right. And now I'm going to cut one of its longer edges. So, going to cut one of a longer edge, right, and just place it on a plane surfaces to obtain the development of the carton. What I am going to do is just cut the carton in this longer edge. It has 4 longer edges, right? One of the edges, the extreme left, I am just cutting it and just unrolling or unfolding this particular object, this carton, from behind to right. So, now you could see the 4 rectangular surfaces, right. So, you could see in this manner. So, 1, 2, 3, 4. Got it? So, the layout of only the sides, layout of only the sides of the object without the top and bottom base is the lateral surfaces. So, that means only side in the sense, these are sides, right, these are sides. The layout of only the sides of the object without the top and bottom is called lateral surfaces. See, as far as our syllabus is concerned, it is only for the development of lateral surfaces. Got it? Right. So, this is how the object would be shown. Right. Fine. See, the surface which is generated by moving the straight line is called plane surfaces. For an example, if the object, this is a square prism. Right. So, look at here. This is a line, right. So, if I just moving this straight line, you will get the surface. This is a plane surface or the lateral surface. Got it? And that is generated in a curved shape, which is nothing but the curved surface. Surface which is generated by moving a straight line is called plane surface, and that is generated by a curve is called curved surfaces. Got it? So, solids bounded by plane surfaces. Examples are prism. All the prisms, like square prism, rectangular prism, then hexagonal prism, pentagonal prism, triangular prism, isn't it? Then pyramid, all the pyramids, and tetrahedron. Tetrahedron has 4 equilateral triangular faces, isn't it? Right. Solids bounded by plane surfaces are prism, pyramid, and tetrahedron. Then solids bounded by single curved surfaces. This is nothing but the cylinder and cone. Cylinder and cone. Got it? So, see, for the projections of planes, we used a method which is nothing but the change in position method. Similarly, for the projection of solids also, we used a method which is nothing but the again the change in position method or rotating the solid method, isn't it? Similarly, for the development of surfaces also, we have methods of development of lateral surfaces. So, methods of the development of lateral surfaces. Lateral surfaces. See, as far as our syllabus is concerned, we develop only the lateral surfaces. So, under this we have two. One is parallel line development. Parallel line development method, and the other one is radial line development method. See, parallel line development, this method is used to develop the prisms, cylinders and cubes. This method is for prism, all kind of prisms, then cylinders, prisms and cubes. And for the radial, it is for the pyramids and cones. Let me just explain the parallel line development. This method is used to develop the cubes, prisms and cylinders, in which all the edges or generators of the lateral surfaces are parallel to each other. So, for an example, I just cite an example to you in a short while. Okay, the prisms and the cylinders roll out into a rectangle stretch outs by this method. For an example, assume this is a lateral surface. So, I am just going to cut off. This is assume lateral surface. I am just going to cut this on the longer edge. Now, I am going to stretch out or unrolling or unfolding the lateral surfaces from back to the right, this manner. Right. When I just stretch out it or unfold it, you could see the rectangular shapes. Right. This is a rectangular stretch outs for this method. Look at here. These are rectangular faces. As being hexagonal prism, it has 6 surfaces. That means, rectangular faces, isn't it? All lateral faces. So, that's what being stretched out here. This is nothing but the lateral surfaces. Got it? And for the radial line development, this is a method which is used to develop the pyramids and cones, in which the apex is considered as center and the true length of the slant edge as radius for these development methods. See, for the pyramids and cones, when it's when you just roll out into the isosceles triangle for pyramids and the sector of a circle for cones respectively. Right. When I just cite an example to you, it would be easy for you to grasp it. Okay. See, the engineering application of development of surfaces is nothing but the sheet metal work. See, fabrication of chimneys, fabrication of furnaces, then fabrication of the shipbuilding, aircrafts, those fall under the development of surfaces, right. So let me just give some example for it. So for an example, this hexagonal prism, now I am going to draw the development for it. See, when you just draw the 2D, that is two-dimensional object, that is a orthographic projection. For orthographic projection, you just draw XY above VP, HP. If you draw the shape in this manner, and you will get in this manner, right. When you just cut open the one of the long edge and just stretch it out, it will look like in this manner of 6 rectangular faces. This distance could be the perimeter. This distance could be perimeter of hexagon. So what is the perimeter formula for hexagon? So perimeter of hexagon. How many sides it has? It has 6 sides. Hexagon has 6 sides. That means n into a. N is nothing but number of sides, 6. A is nothing but the side dimension, that is 25 mm side or 25 mm edge, right, or 20 mm or 30 mm, whatever. So assume if it is 20 mm side, then it could be 120 mm. Then this is the length of the lateral surfaces of the development for the hexagonal prism. Suppose it is a pentagonal thing. For pentagon, it could be 5 into a. For square or the cube, it could be 4 into a, because number of sides could be 4, isn't it? So this is the lateral surfaces. When the top and bottom faces are there, then it would come in this manner. It could be in this manner. When you just fold everything, you could see the top face and bottom face and all the rectangular faces. When you just cut open the one of the longer edge and just stretch out from the rear to the right side, you could see the lateral surfaces of the object. The object is the hexagonal prism. This is for prism, right? So when the cylinder, the development of lateral surface of the cylinder. So this is the cylinder, isn't it? This is a cylinder. Suppose I cut the extreme left, cut it and just peel off or unrolling or unfolding or stretching out the lateral surfaces from rear to the right side, what you could see. Say for the XY line, above VP and HP, you could see a circle in the top view and you could see a rectangle in the front view, isn't it? So this would be the center, right? So when I just cut it from the left extreme and stretch it out or unfolding it, you could see in this manner. Since it doesn't have any edges or corners, you could see only the rectangular shape. What would be the distance? What could be the distance? This is the circumference length of the circle. That is nothing but pi d. Circumference length of circle formula is pi d. So this is the lateral surfaces. This is the lateral surface for this particular object. Got it? And if you want to draw the top and bottom faces, it could be in this manner. When you just fold it, you could see the cylinder shape. That means top face, bottom base, and the generators. Got it? Fine. So this method is nothing but the parallel line method. So look at here, everything is parallel. This is parallel to this, and this bottom is parallel to this. Got it? So this is parallel line method. For prism Q and the cylinder, we use the method parallel line development method. Now I am going to show the stretch outs for the pyramids and cones. So the method which is used for pyramids and cones is nothing but the radial line development. For cone, for an example, this is the top view, this is XY. So this would be the front view, and this would be the top view. When I just cut in the left side, that is nothing but the slant height. This is generator. The extreme generator, if I just cut it and just cut it open, this is the object. Now just cut it, one of the generator, right? In the left extreme, just cut it and just stretching out or unrolling it or unfolding it to right, you could get a sector of a circle. It will look like in this manner. This would be the length. This would be the slanting height or slanting length. This distance is nothing but the apex to this is the line, the line from the apex to the base is nothing but the slant length or slant height. So measure it, this one. This could be your apex, isn't it? So apex. So now make a curve, the arc which is close here. So theta is nothing but the formula we have learned in epicycloid and hypercycloid, isn't it? Theta is equal to R by capital R into 360 for epicycloid and hypercycloid. For here, R by SL into 360. So R is nothing but the radius of the circle. SL is nothing but the slant length or slant height of the cone into 360. You will get some values in degree. You will get some values in degree. That is the value. So you will have to draw the slant length, then make an arc for the theta. Right. So this could be something like this. If the cone is here in this manner. If you fold it, you could see the shape of a cone. Fine. So the method which is used to develop the lateral surfaces for cone is nothing but the radial line development. Now I am going to draw the lateral surfaces for pyramid. So yes, symbol diagram of a square pyramid. This is the apex, this is the center. So this is how it looks like. If I cut the slant edge, one of the slant edge, and stretch it out behind, this is what the object, right? If I just cut this, one of the slant edge, and stretch it out to right, that means from rear to the right, you could see the isosceles triangle, right? Isosceles triangle. So this length is the slant length, right? The slant edge length, right? So now just measure it in your compass and just draw a line and then put an arc. You know the side of the pyramid, right? So just cut an arc, just go on cutting it. just cutting it. Somewhere it ends. So now connect it. So you could see the isosceles triangle, 4 isosceles triangle, because look at here, this lateral surfaces of the square pyramid of 4 isosceles triangle. Now look at here, the base is of edge, that is a line. So you'll have to just do it in this manner. Straight lines, straight lines. Right. So this is the lateral surface development for the pyramid. This is the base. When you just fold it, you could see the shape of square pyramid. Fine. So in the upcoming videos, I will just explain in a detailed manner about the parallel line development by using the parallel line development for prism, cylinders and cubes, and by using the method of radial line development for pyramids and cones in a detailed manner. Hope you have all understood this. Thank you.